Imagine holding two metal bars in your hands. One is steel, the other is titanium. At first glance, they look similar. But the titanium bar could cost several times more. Why titanium? It's one of the strongest metals on Earth. It's used in fighter jets, spacecraft, luxury watches, and even inside the human body. But here's the strange part. Titanium isn't actually rare. In fact, it's one of the most abundant elements in Earth's crust. So why is it so expensive? Why can a small piece of titanium cost several times more than steel? Is it controlled by a few countries? Is it incredibly difficult to find? Or is there another reason almost nobody talks about? The truth is far more surprising. Because the world's biggest challenge isn't finding titanium. It's turning it into metal. And that journey is one of the most difficult manufacturing processes ever created. By the end of this video, you'll understand why companies are willing to pay thousands of dollars for something that's hiding almost everywhere beneath our feet. Let's begin. Imagine you're standing in a mine. Massive machines are digging into the earth. Truck after truck carries away tons of black sand and heavy rocks. Hidden inside them is titanium. At this point, you might think the hard part is over. Just melt it like iron and turn it into metal. Simple. Right. Not even close. Titanium has one characteristic that makes engineers hate it and love it at the same time. It reacts with oxygen almost instantly. The moment hot titanium touches air, it begins reacting with oxygen, nitrogen, and even hydrogen. Those reactions can ruin the metal completely. That means you can't simply melt titanium ore inside a normal furnace. If you try, you'll end up destroying the very material you're trying to produce. So engineers had to invent an entirely different process. A process so difficult that it changed the price of titanium forever. The solution is called the Kroll Process. And it's one of the biggest reasons titanium costs so much. Everything starts with titanium ore. But engineers can't use it directly. First, the ore is crushed, cleaned, and heated to extremely high temperatures. Then it's mixed with chlorine gas. The result is a dangerous chemical called titanium tetrachloride. This liquid is highly toxic. It fumes in the air and reacts violently with moisture. Just getting to this stage already requires expensive equipment and strict safety controls. But here's where things become even more difficult. The titanium still isn't metal. To remove the chlorine, engineers place the chemical inside a sealed reactor. Then they add molten magnesium. A powerful chemical reaction begins. Slowly, the chlorine separates and what's left behind looks nothing like shiny metal. Instead, it becomes a rough, gray, porous material, known as titanium sponge. Yes, a sponge. Not a solid metal bar. Not a sheet. Not a rod. Just a strange-looking mass filled with tiny holes. Most people think this is the final product. But it's not. Not even close. The sponge must be crushed, cleaned again, tested for purity, and then melted inside a special vacuum furnace. Why a vacuum? Because even a tiny amount of oxygen can contaminate the titanium. Inside the furnace, temperatures rise above 3,000 degrees Celsius. The metal slowly melts. Impurities are removed. And finally, for the first time, a solid titanium ingot is created. Only now can manufacturers begin making aircraft parts, medical implants, or spacecraft components. Think about that. Before a single airplane bolt is manufactured, titanium has already gone through multiple dangerous, expensive, and time-consuming steps. Every one of those steps adds to the final price. And that's why titanium is valuable. Not because it's rare, but because turning ordinary rock into perfect titanium is incredibly difficult. So, after all that effort, what makes titanium worth it? The answer is simple. Titanium does something very few materials can. It's incredibly strong. Yet, it's much lighter than steel. Imagine building an airplane. Every kilogram you remove saves fuel, reduces operating costs, and increases efficiency. That's why modern aircraft depend on titanium. You'll find it inside jet engines, landing gear, airframes, and many other critical parts. But airplanes are only the beginning. Titanium has also reached outer space. Every kilogram launched into orbit costs a fortune. The lighter the spacecraft, the lower the launch cost. That's why titanium has become one of the most trusted materials in the aerospace industry. Now let's go somewhere completely different. The human body. Most metals slowly corrode or trigger unwanted reactions. Titanium is different. The human body accepts it remarkably well. That's why surgeons use titanium for dental implants, artificial joints, bone screws, and medical plates. Imagine that. The same metal used inside rocket engines can also become part of someone's smile. But titanium's story doesn't end there. Deep beneath the ocean, some submarines rely on titanium to survive crushing water pressure. It also resists seawater far better than ordinary steel. That's a huge advantage for ships and offshore equipment. So here's the obvious question. If titanium is this amazing, why don't we build everything with it? Why not cars, buildings, bridges, even kitchen knives? The answer comes down to one word: cost. Steel is much cheaper, much easier to produce. And for most everyday products, steel is already good enough. Engineers choose titanium only when its unique advantages are worth the extra expense. So, the next time you hear the word titanium, don't think about a rare metal. Think about one of the most difficult manufacturing journeys ever created. Because titanium isn't expensive simply because it exists. It's expensive because transforming ordinary rock into one of the world's greatest engineering materials requires extraordinary effort. And that's the hidden story behind titanium. If you enjoyed discovering it, subscribe to Story Behind the Things. Because we uncover the hidden stories behind the objects, materials, and inventions that quietly shape our everyday lives. Thanks for watching. And as always, stay curious.